Hi everyone, welcome to another session of Python programming. So today in this class we are going to cover number systems. What are the number systems that we follow in Python? Okay, so basically all the programming languages they have to follow some number systems because we use often so many numbers, so many letters. Okay, so we use all these things in our programming. So similarly, like other programming languages, Python is also follow some number systems. Okay, so basically this is the concept which already we have learned in C programming. Okay, so the general number systems that we know, those are decimal, binary, octal, and hexadecimal. Okay, so here also in Python also we use the same kind of number systems. So decimal number systems where it starts from 0 to 9. Okay, so it has all the numbers of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then whereas in binary number system we follow only two values, whereas 0 and 1. So 0 represents off state and 1 represents on state. Okay, so any kind of thing is represented in the form of 0 and 1. Similarly, we have an octal number system where we have a set of numbers from 0 to 7. Okay, then we have an hexadecimal number system. So it consisting of near 16 numbers 0 to 9 and from A to F. Okay, so these are all the number systems that we are using in Python also. Likewise in other programming languages, here also the same thing, there is nothing difference. Okay, so here also we have to know about how these number systems can be converted into some other systems, like decimal is converted into binary, binary is converted into octal, octal into hexa, hexa into octal. Okay, right? So all these number systems, how these conversions happens. Okay, again we have to know all these again basics things. Already we have learned about these conversions or the representations of these number systems in other programming languages also, but in this concept also I'll try to revise all the concepts that we have learned in other subjects also. Okay, so there is nothing new here. So likewise how we convert the systems into other number systems, whereas in other programming languages the same thing here also we follow. Okay, so let's see each and everything in detail. So the first one is a binary number system which uses only two numbers, either 0 or 1. Okay, so the base number system that we have is decimal. So any kind of number, so the basic number, suppose if I told you to represent 129, so the basic representation of 129 is in decimal number system. Okay, so from the decimal number system then we can go on converting either it into a binary or octal or hexadecimal. Okay, so the base number system that we follow in any kind of programming languages, which is a decimal number system, okay, which accepts 0 to 9 numbers, right? So that I am not going to again repeat it here. So we'll directly go into the binary number system. So whereas in binary number system we uses only two symbols, 0 and 1. 0 represents off state, 1 represent on state. So you can see a small example here, binary number of 1001111. That is a number system. If you convert that number system into a decimal number system, you will get some value. Okay, so 1001111, it is a binary number system which is only understandable by the machine. As a user, we don't understand what is this 1001111. Okay, so we need to convert this into a decimal number system. The decimal number system is the system which we understand. As a user, we understand the systems. Okay, so how can we convert that into a decimal number system? So from this number, so basically decimal number system, binary number system uses only two numbers, right? So we need to have a kind of thing. So this first number from the right hand side, the first number is at the place of 2 power 0. The The second number is at the place of 2 power 1. The third number is at the place of 2 square. Okay, like 2 power 3, 2 power 4, 2 power 5, 2 power 6. Okay, so this is how the representation of the numbers. So from the right hand side, we need to follow that the first number from the right hand side is at the place 2 power 0 at the place. Okay, why 2 power 0? Because in binary number system we use only two numbers or two symbols. So that's why we are taking it as a 2 power 0 at the place. Okay, so how can we get the decimal number system from this number is 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 square into 1. Like that, we need to multiply these numbers with their places. Once again I am repeating, we have to multiply these numbers, this 1, 1, 0, 0, 0, all these numbers with their places. Okay, so you can see from here we are writing, I am writing the thing 2 power 0 into 1, then 2 power 1 into 1, 2 square into 1, 2 power 3 into 1. Okay, then the fourth place I have 0, so 2 power 4 into 0, 2 power 5 into 0. Again this place is 1, so 2 power 6 into 1. Okay, so when you combine all these values, obviously this 2 power 5 into 0 and 2 power 4 into 0 will give the result as 0. So this 2 power 6 into 1, that will give some number, then again this will give some number. Okay, again this one. So you need to add all these terms and you will get the number as 79. Okay, or otherwise we can follow the 8421 code. We have 8421 code. Okay, so 8421 code means what? This is 8, the last 4 digits. This forms an 8421. Okay, so this 1 is at 8, this 4, this is 2, this is 1. 8421 code we call it as. Then this number is having larger than this 4 digit representation. So now this obviously become 8421, this become 16, this place become 32, this place become 72, sorry 32, 32 is 64. Okay, so like this we can represent here. Okay, otherwise this is the standard procedure. We need to multiply the number with their places. Okay, so then we will get the number as 79. So this is the general binary number system. Now in Python, if we want to convert a binary number system into an integer, okay, or an integer into a binary number system, there is some methods. There are some methods through which we can convert any number into binary or decimal. Okay, so if you want to convert any number into a binary number, then we can use this function bin. Bin is a function which can be used to convert any number into a binary number. Similarly, if you want to convert any binary number into its normal form, that means into its decimal form, we use simply an integer function, int integer function. Okay, ma? So bin is a function which can be used to convert any integer number or any number which is in decimal system into a binary number system. Okay, if you want to perform the reverse thing, that means binary number into some decimal number system, then we need to have a function called int. Okay, so as you can see on the screen, we are taking a number a is equal to 79. Okay, and this 79, I have to convert this 79 into binary number system. Okay, then I'll take a variable called bin underscore a, because I need to store the result, right? So that result will be stored in bin underscore a. Then what I am doing, I am calling a function bin. In bracket, I am passing a value, okay, to which I want to convert a binary number. So bin of A. What is A? 79. So I need to convert this 79 into a binary number, and that result will be stored in bin underscore A. Okay. So when you print the value, print bin underscore A, you will get the binary number of 79. Okay. Actually, from this, I need to consider this. These two places are meant for representing a binary. OB means a binary number. Okay. Similarly, OC means octal number, and OX means that is hexadecimal number. So these are the places I need to consider. From this one to the remaining places I need to consider. Okay. So how can we convert a normal number into a binary number? By using a function called bin. Okay. To that bin function, I need to pass the number to which you want to convert it into a binary. Now, what if I need to convert the same number into its original form? Original form in the sense, again decimal. Okay. Then I need to call a function int. Okay. I need to call a function int. Then to this int function, I am passing two parameters. One is bin underscore A. What is this bin underscore A? It contains the binary format of 79. Isn't it? Okay. Bin underscore A contains binary format of 79. Okay, that number should be given as an input, comma 2. Okay, because binary is what? Binary is for base what? 2, right? So we need to give base 2. These two parameters have to be given to the integer function. Then this integer function will calculate and gives it as a normal number. Okay, because how we get a decimal number from the binary number? We need to multiply with 2 power 0 into 1, 2 power 1 into 1, like that, right? So what is that base 2? So that base 2 has to be given as an input parameter to the integer function. Okay, so once again I am repeating this. Int is a function which will convert the binary number into a decimal number. Okay. Then what are the parameters that I need to pass to an integer function? Integer function will take two parameters. One is the binary number to which you want to convert into a decimal, comma, what is the base of a binary number? Binary number, the base of a binary number is 2. So these two parameters has to be passed to the integer function. Okay. So when you pass these two parameters to the integer function, you will get the result as 79. Okay. Hope you understood this. Next, octal number system. So we know that octal number system is base 8. What is the base of octal number system is 8. Okay, because we represent from 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay, total how many numbers? 8 numbers. So these 8 numbers will be considered as a base. Okay. Now, if you want to convert any number into octal number, then only thing you need to do is multiply that number, the places of their number into with their bases. Suppose, see here, there is an octal number 117. Okay. How can I convert this into a decimal number? Obviously, this 117 is an octal number. Okay. So the first place from the right hand side, the first place is represented as 8 power 0th place. 8 power 0. Because 8 is the base, right? For octal number, the base is 8. So 8 power 0 into 7 plus 8 power 1 into 1 plus 8 square into 1. Okay. So when you multiply all these, when you add all these things, you will get the result as the octal number 117. When it represented in decimal number, we will get the answer as 79. Okay, 79 is the answer when you convert 117 into a decimal number. Right, ma'am? Have you understood this? Only thing is places. 7, this is the 0th place, 0, 1, 2, like that we have to consider the places. And we need to multiply with the base. Base into exponent, that means base power exponent into 1. Sorry, into that number that we need to consider here. So from the right hand side, we can say that this 7 is stored at 8 power 0th place, 1 is stored at 8 power 1 place, and again 1 is stored at 8 power 2 place. Okay, so we need to multiply with the these numbers into base power exponent value. You will get the answer. Next, Python uses a special kind of function directly to convert any integer number into a octal number. Okay, so we use a function called oct, oct. Oct is a function which can be used to convert any decimal number into a octal number. Okay, any decimal number into a octal number. Like in the previous case, bin is a function which is used to convert any decimal number into a binary number. We use a function bin, bin, then brackets. Similarly, here we use octal number. Okay, so for conversion of an octal number, we use OCT. Oct is a function. So you can able to see here, I am taking a value a is equal to 79. Then I am converting oct OCT of a. Okay, so converting converting 79 into an octal number. Now I am storing the result in OCT underscore a. When I try to print OCT underscore a, I will get the answer as 117. Okay, forget about these first two places. I told you in the previous case, okay, these first two places represent the type of number it is. Whether it is binary, it represents 0b. Okay, whether it is octal, it represents 0o. Okay, so the remaining places we need to consider. So 117 is the output. So when you convert 79 into an octal number, you will get the answer as 117. What if I want to perform the reverse thing? That means converting an octal number into a decimal number. Okay, similarly, in the likewise in the previous case, again here also we use an integer function, but while passing the parameter, I need to pass an octal number, comma, its base. Okay, what is the base of an octal number? 8. So OCT underscore a contains an octal number. What is an octal number here? 117. So 117 comma, what is the base of an octal number? 8. So I am giving these two parameters. When I am giving these two parameters to an int function, it will convert octal number into a decimal number. So you will get the result again as 79. Okay, hope you understood this. Next, hexadecimal number system. So hexadecimal number system, it is a number system which contains 0 to 9 numbers and the alphabets A, B, C, D, E, F. Okay, and the base of a hexadecimal number system is 16. The base of a hexadecimal number system is 16. Okay, so when you have a hexadecimal number and if you want to convert that into a decimal number, you need to consider the base power exponent. Okay, so what is the base here? 16 is the base. So 4f can be represented this from the right hand side. F is stored at 16 power 0 place. 4 is stored at 16 power 1 place. Okay, so 16 power 0 place, F is stored, and 16 power 1 place, 4 is stored. So 16 power 0 into F plus 16 power 1 into 4. If at all you have any other number here, then it can be multiplied with 16 power 2. Okay, so this 4f, when you convert into a decimal number, you will get the answer as 79. Okay, right. Okay, again we have hexadecimal. When you have an hexadecimal number or when you have any decimal number, if you want to convert that into a hexadecimal number, again we have a function called hex. Likewise in bin and oct functions are there. Similarly, when you want to convert any decimal number into a hexadecimal number, we have a function called hex, hex. Okay, so see this example. A is equal to 79. Again I am taking the same example. A is equal to 79. When I want to convert that into a hexadecimal number, I need to call a function hex. Hex in the bracket, I need to give that number. Okay, so here 79 is stored in A, so that I am giving A as a parameter. Now the result will be stored in hex underscore A. Okay, I have taken a random variable. Hex underscore A is a random variable which I can use. But it's not mandatory that we can use only that name. We can use any name, no problem. Okay. So your result will be stored at hex underscore A. When you want to print hex underscore A, it will give the answer as 0x4f. Forget about these first two bits. Okay, so these first two bits represents the type of a number system. 0x for hexadecimal, 0O for octal number, 0B for binary number, and the remaining places represent your number. So here 4f is representing. So what is 4f? 4f is nothing but it is a representation of a hexadecimal value of a decimal value 79. Okay, when you have a decimal value 79, when you want to convert that into a hexadecimal value, that will be stored as 4f. Okay. Similarly, like we have did in last two examples, if you want to convert this hexadecimal number again into an integer value, only thing you need to do is calling an int function again, and while giving the parameters, I'll give the first parameter as hex underscore A. What is hex underscore A contains? The hexadecimal form of 79. Okay, comma, what is the base of hexadecimal number? 16. When I give these two parameters and calling an int function, then it will give the decimal value version of this particular number. Okay, so what is the decimal value of 4f? 79. What is the hexadecimal value of 79? 4f. Okay, so that is how we need to convert from one system to another system. Okay, what if I want to convert from octal to hexadecimal? Octal number to hexadecimal. The direct conversion is not possible. Okay, so from octal to, you need to convert it into a decimal, and from decimal to, we can convert it into a hexadecimal. Okay, try to remember this. When you want to convert from octal number to hexadecimal number, the direct conversion is not possible. Okay, you need to convert that into a decimal value first, and from decimal value you need to convert it into a hexadecimal value by using these functions. Okay, so we can use this oct function and hex function. We can do this. Okay, right. So this is somewhat we have direct functions, which is oct and hex and binary, right? So we have learned about three functions in this class: bin bin function, oct oct function, hex hex function. So these three functions are nothing but which can convert any decimal value into their own representations. Okay. So without using this function, can we convert the thing? Without using these functions, I don't want to use these built-in functions. See, these three are built-in functions. Again, I am repeating this. These three are the built-in functions. Already these functions are defined in Python library. So we are not writing it on our own. There is a function which already exists in the system, or which exists in the Python library. Here only we are using those functions. Okay, I am simply using those functions. I am not directly writing the definition of that function. Okay, so these are the three number systems that we have. Next is Without using these functions, how can I perform this thing? How can I perform this conversion? Without using these functions. I don't want to use this opt function, bin function and hex function. Okay. Functions use Chekunda. Then how can I perform these conversions? Okay. So we'll just try to learn about binary to decimal and decimal to binary. Then the remaining process will be the same. Okay. See here, binary to decimal. What is this binary? Binary means what is the number system of binary? 2. The base 2. 2 decimal version. Decimal is the sense. What is the base of a decimal number system? 10. Okay. So binary is base 2 and decimal is base 10. Now, how can I convert from the binary to decimal? Okay, so you can see a small program representation here. So first of all, I am taking the binary string. Okay, writing a print statement, like printf statement in other C programming languages. We have an input function, right? In Python, we have to use an input function to get the input from the keyboard. So first statement b string is equal to input, enter the string of bits. Okay, so you need to enter a binary number here. Which is of the form 1010 something like. Okay. Now we have to use another variable called decimal in which our output will be stored. So you want to convert binary into decimal, right? So binary is a variable which called as a b string. So in this variable binary number will be stored. And decimal is a variable which is your result will be stored. So initially I am giving it as a 0 because I need to use this variable, right? So that's why I am giving 0 here. There is nothing to store first. Next. Exponent. See, basically for any number system, you need to find out what is the base and what is the exponent. Okay. Exponent value means what? 2 power 0. Here in 2 power 0, 2 is the base. 0 is the exponent. Okay, 2 power 0 contains 2 is the base and 0 is the exponent. Okay, so here I need to traverse length of the b string minus 1. That means first of all I need to travel from left hand side to right hand side, because I told you the calculation will be always done from the right hand side. 2 power 0 into 1, 2 power 1 into some number, 2 power square into some number, right? So from the right hand side I need to follow. So that's why I need to use this function length of b string minus 1. Okay, so we can do it in both ways. Here when I'm representing this, I can perform in both ways. I can either from right to left I can do, or from left to right I can do. See, you can see this. Okay, so see here. So how many total number of places are there? Starting from this right hand side, 2 power 0, 2 power 1, 2 power 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. So 2 power 6 to 2 power 0, these are the places. Okay, so we can do both ways, that 2 power 6 into 1, 2 power 5 into 0, 2 power 4 into 0. Okay, I can use that that means the representation of in that manner, or I can start from the right hand side also. Okay, from the right hand side or the left hand side, but you need to be careful with the exponent. Okay, so similarly when the conversion program, what I will try to do is I need to find out the total length of the string. Okay, ఈ length మొత్తం ఎంత ఉందో నేను find out చేస్తాను. ఎన్ని digits ఉన్నాయి? 4 digits ఉన్నాయి. Okay, so this 4 minus 1. What is 4 minus 1? 3. Okay, so now 2 power 3 is the last index I need to consider, because I'll start always with 2 power 0, right? So 2 power 0, 2 power 1, 2 power square and 2 power 2 cube. So what is the first index? 2 cube. 2 2 cube is the first index. So first of all, I need to find the length of the string minus 1. If at all I have 5 numbers, then what is this exponent contains? 2 power 4. Okay. So likewise, I need to always subtraction 1 from the original length of the string. You subtract 1 from the original length of the string. Now there are 4 numbers, 1, 1, 1, 1. Okay, I need to multiply each and every number with their base power exponent. అంతే కదమ్మా, ఈచ్ అండ్ ఎవ్రీ నెంబర్ని ఏం చేయాలి, బేస్ పవర్ ఎక్స్పోనెంట్తో మల్టిప్లై చేయాలి. సో 2 పవర్ 3 into 1, 2 square into 1, 2 power 1 into 1, 2 power 0 into 1. That is what I need to calculate. So to traverse from first value to the last value, I am taking a for loop. For digit is a normal variable. Okay, you can write n also here. Okay, n also you can take. For n in b string you can take it, or for digit I am using a digit variable. So for digit in b string, now decimal is equal to decimal plus what I need to convert that digit, that means this first one will be converted into an integer, because when you take it from the input in Python programming, each and everything is in a string format. Try to observe that anything when we give input from the keyboard in Python, it is a string variable. By default, it is a string content. So you need to convert that string into an integer value. So this one will be converted into an integer value by using a function int into 2 power exponent. What is exponent? Here 3 is the exponent. So 2 power 3. So 2 power 3 in Python will be represented with this double star symbol. Okay. So power function can be represented with the help of a double star in Python. So that's why int of digit, that means 1 will be converted into an integer which is 1 into 2 power. So power will be represented as double star. So 2 power exponent 2 power 3. What is the exponent value here? 3. Okay, now, so first step is already done. So 2 power 3 into 1, the result will be stored in decimal. What is 2 power 3 into 1? 8. That 8 will be stored in decimal. Now what happened? I need to subtract the exponent minus 1, because 2 power 3 into 1 is already done. Now what I need to calculate? 2 power 2 into 1. So exponent తగ్గాలి కదా, exponent తగ్గాలంటే ఏం చేయాలి మనం? Exponent value ni ఒక 1 value minus చేయాలి. So we need to subtract 1 value from the exponent. So we need to subtract 1 from the exponent. Okay, then this 2 square into 1 happens. Then again exponent value 1 will be exponent value will be decreased again. Then 2 power 1 into 1. Like that, this total for loop will be traversed from this location to this location. So your final output will be stored in decimal. Okay, your final output will be stored in decimal. So simply you print the value. Print the integer value is decimal. So when you give this decimal, then we'll get the answer as 15. Okay, ma? So I hope you understood this program. So this is the way how we can convert binary to the decimal. Next, decimal to binary. See what when you have a decimal number, binary convert cheyalante em cheyali, aa number ni 2 తో divide cheyali. Okay, so we have to divide that number by 2. ante kada? So which is a normal procedure. So in a number system lo edaina number system nunchi meer convert cheyalante, what is the basic procedure? Suppose మీరు బైనరీలో కన్వర్ట్ చేయాలనుకోండి, నంబర్ని 2తో డివైడ్ చేయాలి. అదే మీరు ఆక్టల్లో కన్వర్ట్ చేయాలనుకోండి, నంబర్ని 8తో డివైడ్ చేయాలి. ఓకే, అదే మీరు హెక్సాడెసిమల్లో కన్వర్ట్ చేయాలనుకోండి, నంబర్ని 16తో డివైడ్ చేయాలి. సో దట్ ఈస్ వాట్ వీ నీడ్ టు కన్వర్ట్. ఓకే, సో ఇక్కడ మనం సేమ్ అదే ప్రొసీజర్ ఫాలో అవుతాం. వీ హ్యావ్ టు ఫాలో ది సేమ్ ప్రొసీజర్ హియర్. So first of all, I am taking a decimal number from the keyboard, input, enter a decimal number. Okay, so by default when you enter some number, it is of the form what? Okay, ma'am. So decimal to binary conversion. So when we have to give the input from keyboard. Okay, input in what format we need to give the input? Decimal number. But by default, Python, whenever we give from keyboard, it will take as a string. So we need to convert this string into an integer. Okay, suppose you are giving 79. That 79 you have to convert into a integer. So we need to write this integer function in front of this. Okay. So your integer value will be stored in decimal. Now, if the decimal value, whatever you are entering, is equal to 0, okay, if you entered 0 as an input, then you have to print 0, okay, otherwise, else, then we need to follow some procedure. Okay, what is the procedure? I am taking a result string, that means result ni store chesukodaniki b string ane oka variable ni తీసుకున్నాను. Then while decimal greater than 0. Okay, first of all I need to check whether that number is greater than 0 or not. Okay, then first thing అనుకోవాలి reminder is equal to decimal percentage 2. Okay, so reminder తీసుకున్నాను. Then after getting the reminder, what I am trying to do is I am rounding off that particular decimal value. Double float ante double modulus symbol use cheste enti dan difference enti, single slash ki double slash ki difference enti? Double slash is a operator which will round off your value, okay, which will round off to the nearest value anamata. Okay, so first of all we need to try to find out the reminder, and that reminder will be stored in a reminder variable. Then the quotient value you need to round it to the nearest number. Okay, then we need to add this reminder value ni manam add cheyali. Okay, so we need to convert this reminder into string plus your b string. B string already contains nothing. At the first place it contains nothing. Okay, so this again the decimal value will be again divided by 2. Okay, and you will get the reminder again. So like that the process has to be continuously performed. Okay, and finally the result will be stored in b string. And while representing the reminder, this total answer, I am using 3 things. One is the decimal number, comma reminder, and b string. Okay, at each and every step. As you can see in the output section, 56 I want to convert 56 into binary number. So 56 ni binary number lo convert cheyalante first em cheyali 2 to divide chestam. So 2 28s 56. So what is the reminder? You will get reminder as 0. And what is the binary number? 0. Next step, again divide 28 with 14. Again 28 with 2. You will get the reminder as 14. Quotient as 14 and the reminder is 0. Okay. And what is the number you can represent? 0, 0. Next, again divide 14 with 2. You will get 7 as the quotient and reminder is 0. Again you will get the answer as 0, 0, 0 here. Binary number representation is 0, 0, 0. Now 7 ni malli again we need to divide this with a 2. So when you divide 7 with 2, you will get quotient as 3 and then remainder as 1. So what is the output? 1 will be added to this string, that is 1, 0, 0, 0. Okay. Again 3 will be divided with 2. Okay. So 2 ones are 2. You will get the quotient 1 and the remainder also 1. Okay. Now this 1 will be again added to this one. So 1, 1, 0, 0, 0. And finally you will get the 0 as quotient and 1 as the remainder. So 1, 1, 1, 0, 0, 0. So 111000 is the binary representation of 56. So this is how we can convert the decimal number into a binary. Okay. What if I need to convert this into an octal number? Then divide it by 8. Decimal percentage 8. Similarly, decimal /8. Okay. Here also, from binary to decimal, here in place of 2, you need to write 8. 8 power exponent into original number. Right? So these two programs are very important. Converting from binary to decimal and decimal to binary. If you understood these two programs, then we can convert it into a octal number or hexadecimal number. Any kind of representation we can represent. Right? So this is how we can write the thing. So that's it for the number system representations. Okay, thank you.